Good morning, everybody. Here I am. While I am recording this video, it is morning. That's why I have said the good morning. Okay. This is the instruction format. In the previous video, we have see the stack organization of instruction. That's zero address instruction format. Now in this video, I'm explaining the one address instruction format, which is also known as the single accumulator organization. In it, we will use a special register, which is called the accumulator. So, what is happening here? In previous video, we have seen the zero address instruction format. What is the disadvantage of zero address instruction format? That the more number of instructions are required for evaluating the y equals to a plus b into c plus d. Number of instructions required are almost 8 to 9, 7 or 8 to 9. So for the sake of the number of instructions, we are using the one address instruction format. What is happening here? Here we are using a special register accumulator, and this accumulator always stores the result of some operation. It always stores the result of some operation, or it can also use to store the data. Mainly it stores the result of operation, but can also be used to store the data. Okay, this is the main point in this one address instruction format. One more thing, in one address instruction format, we use two special instructions, load and store. Load instruction is used to load the data in accumulator, and store instruction is used to store the data of accumulator at some random memory address, some random memory place. Okay, so I'm repeating, load instruction is used to store some data in the accumulator, and store instruction is used to store the contents of accumulator at some memory location. Okay, rest as you are seeing in this video, there is add, the add, some mul mul, the mul is used to multiply. So that is the instruction. There is some noise, some tea is making here. That's the noise of this. It is coming to the winter, so that's because of the tea. So the expression is y equals to a plus b into c plus d. In one address instruction format, there is no need to convert the given expression in postfix notation. That is its benefit. There is no need to convert the given expression into postfix notation. Fine. But as we know, by the hierarchy of operators, brackets have the highest priority. So we are assuming this thing. So first evaluating the a plus b. To evaluate the a plus b, we have loaded accumulator. We have loaded a. Load a. What load a will do? Load a will store the a into the accumulator AC. AC is representing the accumulator. Okay. After that, the instruction add b is given. Now this is the main point. When you will write the answers, this is the tricking point. In the add instruction, which is used in one address instruction format, when we are writing add C, then what is the meaning of add C? Meaning of add C is AC equals to AC plus C. Okay, for the not making of confusion, I'm at the place of C. You can assume the register K. This is only assumption. So in one address instruction format, whenever we will write add B or add K or add C or add L, so the after execution of add B or for example add K, what will be occur there? Content of accumulator will be added with the K, and the resultant will be stored in the accumulator. Okay, that is the main point in one address instruction format, where we do make the mistake. So what is the meaning of add B here? Why we have written the add B? What add B will do? Add B means AC equals to AC plus B, means content of accumulator will be added with the content of B, and the resultant will be stored in AC. Okay, now for more explanation, if you can see previously what AC is containing. AC is containing A. Okay, I have deleted it. So now what it has become? It has become accumulator. Now accumulator will contain the A plus B. Okay, for making the thing clear, because this is the main point in one address instruction, after load A, why add B is written, load B is not written. At the place of load A, we can also write the load B, but let's assume that as in zero address instruction format, after push A we have done the push B. So after load A, if we are writing the load B, sorry, अभी मॉर्निंग में मैंने पराठा खाया. आई एम एन इंडियन ऑफ यूपी. सो if we will do the load B, so what exactly will become? Load A is doing accumulator will contain the A. Okay, now if we will again write down the load B, so now accumulator will contain the contents of B. Contents of A now will be removed. Contents of B will be overwritten on content of A. Accumulator can hold only a single data. Accumulator can hold only a single data. That is because of we are using this kind of instruction. Okay, I think that should be clear now. You can also go to other references. Okay, so okay, so because accumulator is containing the contents of A, and add instruction in one address instruction format is adding the data of B with the contents of accumulator and storing the result in the accumulator. This is happening. That is because of after the load A we are writing add B. यही अगर मीन्स क्लियर होगा कि लोड ए के बाद ऐड बी हमने क्यों लिखा, तो चीज़ को रटना नहीं पड़ेगा. ओके, फाइन. आई थिंक दिस इज़ मोर देन सफिशिएंट. You can say that कि बंदा चीज़ को रिपीट कर रहा है, वॉट एवर आई एम ट्राइंग इन द वे. ओके, अब हमें एक्यूमुलेटर को दोबारा यूज़ करना है. मीन्स नाउ एक्यूमुलेटर in the entire process of one address instruction format, what is the main thing that कि accumulator क्या contain कर रहा है, what accumulator is containing. So now accumulator is containing a plus b. Okay, now if now we have to evaluate the c plus d. If we will write down after this add b, if we will write down load c, if we'll write down this, so what will happen, accumulator now accumulator will contain the c, accumulator will contain the c, and the data what we have gotten a plus b will be overwritten. मीन्स a प्लस बी गायब हो जाएगा और उसकी जगह पर c आ जाएगा. इसका क्या मतलब है, व्हाट डज दैट मीन? दैट मीन्स कि हमें a प्लस बी को टेम्परली कहीं स्टोर करना पड़ेगा. दैट इज़ व्हाट इज़ डन बाय स्टोर t. दिस स्टोर ऑपरेशन, जैसा कि पहले एक्सप्लेन किया था, स्टोर ऑपरेशन क्या करेगा, स्टोर ऑपरेशन एक्यूमुलेटर के कंटेंट को एक टेम्पररी रजिस्टर टी में स्टोर कर देगा. स्टोर ऑपरेशन विल स्टोर द कंटेंट्स ऑफ एक्यूमुलेटर इन अ टेम्पररी रजिस्टर टी. ओके, नाउ टी इज होल्डिंग, now what t is holding, t is in fact holding a plus b. Okay, you are getting the point. Now if you have gotten the explanation of load a, add b and store t, then understanding of load c, that is now accumulator ac will hold the contents of c. Okay, accumulator will hold the contents of c. Then we have executed add d. So as previously explained, what add d will do on the execution of add d, this will happen. On the execution of add d, what will occur, contents of accumulator contents of accumulator will be added. This contents of accumulator will be added with the contents of d or with the d, and the result will be stored in the accumulator. Means d plus c, d plus ac, and is stored at the accumulator. In fact, this is c plus d. Means now t is holding a plus c and accumulator is holding c plus d. Now you can understand that we have to multiply in between the a plus b and c plus d. So the multiplication will happen in between the t and ac, which is written here mul, mul means multiplication, and multiplication in between the content of accumulator, which is c plus d, and content of t, which is a plus b. And again, as you have gotten that result of any operation is stored in the accumulator. So again here what will occur, content of accumulator will be multiplied with the content of t. content of accumulator will be multiplied with the content of T, and resultant will be stored reverse back into the accumulator. Okay, so if I will replace the values, so AC contains C plus D, and there is multiplication operation, and T contains A plus B. Okay, so A plus B into C plus D is now stored in accumulator. Okay, is now stored in accumulator. So now finally we have to store the value of accumulator at some place. Why we will do this? Because again, when some new operation, when some new expression will be evaluated, and we will use the accumulator for our evaluation, so a new data will overwrite the calculated value. So the content of accumulator will be stored at a register X, or you can say as in this question it is set the Y. Okay, so content of accumulator is stored at the register Y. So this is the entire explanation of the one address instruction format. Students make the main mistake at this point, that how and why we have to use the instruction add B, and what does that mean? Because the meaning of add instruction is different in all four formats. In all four formats, add instruction have four different meanings. It adds in between two values, but which values are these, that is a point. Okay, thank you so much.